Hello everyone. So in this video, we are going to be talking about scientific notation. So what we will be learning in this video is how we can change a general number into a scientific notation and then a scientific notation into a regular number. Okay. So, for a number to be called a scientific notation, it should have the decimal between the first two non-zero numbers. Okay. So let me give you a number for right now. So this number right here is just a general number. But if I want this number to be called a scientific notation, then this decimal must be after the first non-zero number. What does that mean? That this decimal needs to be after this one. Okay, so what I want now is I want the number to look like this. I want the decimal to be sitting here. Okay, so but at the same time, I still want the number to keep its meaning, right? Its value should still stay the same. So I cannot just start calling point 0.0101. I cannot just start calling it 1.01 and that's it. You can't do that, right? You want to put the exponent in front of it so that it actually tells you what is the meaning of that number. Okay, so but again, we want everyone to be showing the numbers the same way, so you can say that everyone sat together and decided that that's how we want the scientific notation to look like. The decimal should be after the first non-zero number. Okay, so what do we need to learn here? First of all, what we need to know is when your decimal is sitting here, and when you change this number from 0.0101 to 1.01, did you make this number big or small is what you want to ask yourself, so that we can figure out what do we do with this exponent here. Okay, so you changed the number from 0.0101 to 1.01, so you have actually made this number bigger, right? If you're making this number bigger, and when you do not have any exponent sitting here, then assume that you have 10 to the power 0. This will just help you figure out the answer. So when you're making this number bigger, then the exponent should be made smaller so that you even them out, so that you're canceling what you're doing, so that your value stays the same. So this number, since you're making it bigger by 2 decimal places, you have to make this smaller by 2 decimal places. So if you make 0 smaller 2 decimal, if you're making 0 smaller by two numbers, 0 then should become -2. Okay, and then that will be the answer. So 1.01 times 10 to the power 2 is the scientific notation of the number, which actually is this. Okay, both of these numbers are actually equal in the value, but the way you're showing them, the way you're presenting them is different. Okay, so let's do some more examples, and hopefully it will clarify what we're doing here. Okay, so let's say 263.56 times 10 to the power 2 is the number that you're given, and you want to change it into a scientific notation. So the scientific notation, what would that look like? So first of all, what we need to do is we need this decimal to be after the first non-zero number, which happens to be this 2. So this number should look like this. First of all, this is where the decimal should be. Now we need to decide what to do with that 10 to the power 2. So guys, this is actually very simple. Okay, so if you have been confused with moving the decimal to the right or moving the decimal to the left, and then what happens to the power, don't worry about that. Just remember this: if you are making this number smaller, you see that 263 is becoming 2.63, you're making it small, you're making this number sad. You need to make the other number, you need to make the exponent happy, you need to make it big. Okay, so if this side is getting smaller, you got to make this side bigger. So 10 to the power 2, it has to become bigger. How much bigger? How much should this 2 become 3 or 4 or 5 or 6 or 7? How do you decide that? You decide it based off the decimal places you moved. Since 263 point become 2.63, you move the decimal places 2 times, you need to make this number bigger by 2 numbers. Okay, so 10 power 2 will become 10 to the power 4, and that will be the answer. Okay, so let me color code it to the same color. This becomes 10 to the power, 10 to the power 4. Okay, so that will be the final answer. Okay, let's keep doing some more problems so that we are confident with this. Okay, so let's say you're given this number, so 0.11256 and parent part 3, and you're trying to change it into a scientific notation. Then the scientific notation should look like what? So this decimal cannot sit there. Decimal should be after the first non-zero number. So the number should actually look like this, 1.1256. You see, that's how we want the number to look like. Then we need to decide what to do with the exponent. So ask yourself, what did you do with the number? Did you make the number big or small? Going from 0.11256, making 1.1256 is making this number happier. You're making it big. So you need to make this number small to compensate. Okay, so since you made this number bigger by 1 decimal place, you got to make this number smaller by 1 number. So 3 will become 2. That's it. And that's the answer. Okay, so they're not too difficult. Just make sure you understand this idea. Okay, all right. So let's do a problem when there's no exponent, like the very first example we did. So let's do one more problem like that. So 186.5 is the number you have, and you want to change it into a scientific notation. So let's try that. So guys, 186.5, if you want to make this a scientific notation, this number should become, first of all, 1.865. Okay, and then you need to put the exponent. Remember from the first problem, when you are not given when you're not given any exponent already in the question, in the number, then you put the exponent for yourself, and that number is 10 to the power 0. You can always place that number, right? It will just make you understand the answer to the problem more easily. So when there's nothing, just put 10 to the power 0. Okay, now you can picture it better. 186.5. Now let's go back to the same thing we were doing earlier. Decide if you made the number bigger or small. What did you do? You made the number smaller. 186.5 became 1.865, became smaller. So this now needs to become bigger. 10 power 0 needs to become bigger. How much bigger? By 2 decimal, say by 2 numbers, because you moved the decimal 2 places. So 10 power 0 should become 10 to the power how much, guys? Pause the way you tell me what should this number become. So 186.5 became 1.865. You made the numbers smaller by 2 decimal places. You need to make this number bigger by how many numbers? By 2 numbers. So 0 becomes 2. Okay, that's it. That's the answer. So this here is going to be the answer. Okay, now you could also, be given a number, in a scientific notation. So 5.053 times 10 to the power, let's say 2. And I ask you, get rid of that exponent thing, change this into a number that has no exponent, then what do you do with it? Guys, this you gotta realize that when you're multiplying a number with a positive power exponent, then you need to make the numbers bigger, right? Multiplying 5.053 with a positive number like 10 to the power 2 means you need to make this number bigger by moving it 2 decimal places. So 5.053, the decimal should move to the right. That's what will make the number bigger, right? So it should actually become this 505.3. It will be the answer. So did that make sense, guys? To get rid of this 10 to the power 2, since this 10 to the power 2 tells you that this number should become bigger because this is a positive exponent, you need to just make this number bigger, and that's it, and you get rid of the exponent. Okay, that's how you change this change the scientific notation into a regular number. So let's do exact same thing, but let's see if this was not 10 power 2, but -2, then what do you do? In this case, what do you need to do, guys? When you're multiplying a number by 10 power -2, it means you need to make this number smaller. Smaller by how much? By 2 decimal places. This is where decimal needs to go. So you need to put in a 0 here. So this becomes decimal 05053, and that will be the answer. Okay. All right. So I hope that makes sense.